Once the heaters have been stretched, the next step is to cut both of their ends to the right length. This length will depend on the desired position of the heater with regards to the thermocouples. Keeping in mind, of course, that all thermocouples should be equally distributed within the heater so that all of them are exposed to the same temperature increments. And of course, the maximum length of the legs of our heater will depend on their predetermined length at the time the nichrome wire was coiled. For the particular case of these heaters, it is important to consider the entire structure of the heater before cutting the legs, including the connectors, the length of the epoxy, which also depends on the depth of the molds, and the desired position of the connector itself. Now, since the depth of the mold is fixed, cutting the legs too short will force us to make a shorter epoxy. On the other hand, too long and we will be forced to push the connectors so they can be embedded in the epoxy, and this might not look like a big deal, but just consider the following. Let's pretend that this is your sensor getting ready for casting. The testing tube is the polyamide tubing and the needle, like this sensor here. This is your connector, and these are your copper, constantan, or nichrome wires. Pretend also that this sticky note is equal to the depth of the mold, and that the red tape is the limit at which you can insert the needle in the mold, which in the case of a real needle is dictated by this resin used to seal the area between the hub and the barrel. Then at a fixed mold depth, short legs will force you to push the entire piece further down so that the needle reaches its desired depth. Now, on the other hand, long legs will force you to push the connector so it can be embedded in the epoxy resin, which bends the wires. Copper, constantan, and nichrome wires are all insulated because, well, after all, they're often in close contact to each other. But the main difference is that copper and constantan are a lot more malleable. Nichrome, on the other hand, if the soldering joint is not strong enough, can easily come undone as a result of the stiffness of the wire when it's slightly bented. Once all the details of the sensor have been considered and the proper length have Once all the details of the sensor have been considered and the proper length has been determined, we proceed to cut the lengths and to remove the coating of both of the legs, making sure all of it is removed. But it is important to remember that we only want to remove the coating from the areas that we know will be soldered. To remove the coating of the nichrome wire, which is also one of those super strong modified polymers, the method that has worked the best for me is using a simple blade and scrape it off as we did with the copper wires.